Hi everybody, in this video we are going to go over section 1 of chapter 6, and in this video we are going to discuss the radian measure. First we're going to introduce the concept of the radian. We're going to talk about how we can convert between radians and degrees. We will discuss how to use radians to compute the arc length of a circle and also the area of a sector of a circle. Alright, so what is a radian? Or what is a radian measure? Well, it is an angle. Or if you have an angle with its vertex at the center of a circle that intercepts with an arc on that circle, which is the same length as the circle's radius, then you have exactly 1 radian. Well, what the heck does all that mean? Well, take a look at this circle right here. We have an angle. Its vertex is at the origin, so this is basically an angle in standard position. It turns out that the angle here is 1 radian, and as a consequence, the arc length here is equal to the radius of the circle, and that defines the radian. So this measure here is 1 radian. If we reduce it by a factor of 2 to 1/2 of a radian, well then this arc length, if it was drawn on the scale, which obviously it's not, would be equal to 1/2 of the radius. And similarly, for this particular case where we have 2 radians, the arc length here will be twice the length of the radius, and actually this one is pretty much the scale. If theta is the central angle of radius r and theta intercepts an arc of length s, then the radian measure of theta is s, the arc length, divided by r, the radius. And so we have our formula for radians. It is nothing more than the ratio of the arc length to the radius, and of course it is in radians. One of the things that you will notice about radians is that the ratio of a distance over another distance. So those units divide out, and the radian measure is actually unitless. However, we tend to attach the unit radians associated with it. That way we don't get confused between radians and degrees. Okay, so how do we convert between radians and degrees? Well, if you recall, the circumference of a circle is 2 pi r. Therefore, the angle for 1 rotation of a circle is, well, c over r, which is our definition for radians, which is 2 pi radians. Well, that actually happens to be equal to 360 degrees, and this is how we get our conversion. As a consequence, 180 degrees is equal to pi radians. 360 is equal to 2 pi, 180 is equal to pi radians. And with that, we can get our conversion. 1 degree is going to be equal to pi over 1/80th of a radian, and 1 radian will be equal to 180 over pi degrees. So, to convert degrees to radians, what do? You take your degree measure and you multiply it by pi over 180 and simplify. And similarly, to convert from radians to degrees, you take your radian measure, you multiply it by 180 over pi, and you have degrees. Okay, so let's go ahead and do this. Our first little chore is going to be to convert these 2 degree measures into radians. Now, in the first one, we can actually come up with an exact value for radians. Now remember, to do the conversion, we are going to take our degree measure, which is 108 degrees, and we are going to multiply it by pi divided by 180. Now, what you'll notice is that 108 and 180 has a common factor, and that factor happens to be 36. And 108 divided by 36 is going to be 3, and 180 divided by 36 would be 5. And that would be our measure in radians. And of course, this is an exact measure. Now for the second one, we can't come up with an exact measure, but we can approximate this, and we are going to approximate this to the 4th decimal place. So for this one, we will take 325.7. We will multiply that by pi divided by 180 degrees. And of course, we'll need a calculator for this, and if we knock this out on our calculator, we should get 5.6845. So this is basically the 4 decimal places that we're looking for, but we need to look at the 5th decimal place and see if we need to round. Well, the 5th decimal place would be a 3, and since that's less than 5, there's no rounding required, so this will round to 5.6 radians. Okay, well, if we need to convert from degree measure to radian measure, we also need to convert from radian measure to degree measure. And chances are, if your radian measure is expressed in terms of pi, you can probably do an exact conversion, and that's what we're going to do for part A. So for part A, we have negative 7 pi over 6. And our conversion is to multiply that by 180 over pi, 180 degrees divided by pi. As you would expect, the pi's cancel. 6 actually is a factor of 180. So we can rewrite this as 180 divided by 6, which happens to be 30. So this becomes negative 7 times 30, which will give us negative 210. Now for the next one, we would need to approximate, and for this one, once again, we're going to approximate it to the 4th decimal place. So for this one, it would be negative 2.92, but it's done the exact same way. We are going to multiply this by 180 over pi, 180 degrees over pi radians. Of course, we'll need our calculator to do this, and if we do, we will have negative 167.3036. There's our 4 decimal places. Let's look at the 5th one. That's a 7. Okay, well, since this sucker right here is greater than 5, this would round up to negative 167.3037. Well, now that we actually have 2 types of measures for angles, we actually need to come up with a bit of a convention so that we know what units are associated to what number. And this is going to be our convention. If you do not see a unit of measure specified for a certain degree, you will assume that it is in radians. So 30 equals 30 radians, which is a lot of spins around a circle. If you do see the degree measure, well, then obviously we mean degrees. For example, these are the equivalent angle measures for some of the more standard angles. For example, 0 degrees, well, that's pretty straightforward. Everything is 0. But for, say, 360, well, the conversion from, 30 degrees, the conversion from 30 degrees to radians would be to multiply that by pi over 180. If you do, you will have a common factor of 30. This reduces to 6, and this would be the exact number for 30 degrees. And of course, this would be our approximation to the 100th digit. Same thing with 45. If you multiplied 45 by pi over 180, you would get pi over 4. And punching that in the calculator, you would get the exact same thing here. Of course, pi over 180, 90 times pi over 180 is pi over 2. Pi over 180 times 180 is pi. And the rest of these are pretty self-explanatory. Another way to look at these is through a circle. And this is a circle, and once again, these are all of the angles that you could compute exactly. Now, these you could compute exactly. Now, and these angles, once again, you can also compute exactly because they are all convenient factors of 180 degrees. And this brings us to our next topic, which is finding the arc length of a circle. So for the arc length of a circle, let's call the arc length let's call that arc length S. And we will say that the length of the arc intersected by a circle of radius r by a central angle of measure theta in radians, what's that equal to? Well, it's equal to the radius of the circle times the angle in radians. So this value S right here is equal to r times theta. And we have some examples about that. So the first one is we have a circle of radius 25.60 meters. And we want to find the length of the arc intersected by a central angle having measure 54 degrees. Well, the first thing that we need to do is take this degree measurement and convert it into radians. So we will have that theta in radians is going to be equal to 54 degrees times pi radians over 180 degrees. Of course, degrees conveniently cancel. And we will have 54 times pi divided by 180 degrees. So that is our value in radians. And we can actually just leave it like this. We could simplify it. There's no reason why we can't. But let's just go ahead and leave it like this. And with that in mind, our arc length is going to be 25.6 centimeters. And now we're going to multiply that by 54 pi over 180. And if I put that to the calculator, I'm going to get 24.12. And actually, since the radius is to 2 decimal places, and there's nothing specified, I'm going to put my answer down in 2 decimal places. But to do that, I want to look at the third decimal place, which is a 7, and that tells me that I need to round up to a 3. So this will round to 24.13 centimeters. Okay, so that's a collection of problems that you are going to find in your homework. And here's another example you will find, and this is finding the difference between the two cities. Here we have that Erie, Pennsylvania is approximately due north of Columbia, South Carolina. I actually did not know that. Okay, it turns out that the latitude of Erie is 42 degrees north and the latitude of Columbia is 34 degrees south. And the radius of the Earth is approximated to 64,000 kilometers. And we want to find the north-south distance between the two cities. Okay, well, to do this, we need to find the angle between those two cities, and that angle is going to be the latitude measurement at Erie, so we will call that theta E, minus the latitude measurement at Columbia, we'll call that theta C. That is 42 degrees minus 34 degrees, and that will be equal to 8 degrees. Okay, once again, we're going to need to convert that into radians. And that will give us that we will start off with 8 degrees. We want to multiply that by pi over 180 to convert to radians. And this will substitute, or this will simplify to 2 pi divided by 45, and that will be radians. And now we can find the distance. The distance is going to be equal to the radius of the Earth, which is 64,000 kilometers. I'm sorry, 6,400 kilometers. Earth ain't that big. Times 2 pi divided by 45. And when you do all that math, you will find that the distance is 893.6 kilometers. And we're going to round this to the nearest kilometer. And this would round to 800, and since this is greater than 5, this will round to 894 kilometers. For our third example, we are dealing with gearboxes or a gear system. And here we have the 2 gears are adjusted, so the smaller gear drives a larger one, as shown in this cute little figure over here. If the smaller gear rotates through an angle of 150 degrees, through how many degrees will the larger gear rotate? Now, the key to this problem, with this particular problem, is that since the gears are connected by these teeth, they are both going to move the exact same amount of distance. The distance that this gear moves will be the same as the distance that that the larger gear moves. As a consequence, distance traveled by the smaller gear is going to be equal to the distance traveled by the larger gear. Now, the distance traveled by the smaller gear is going to be equal to the radius of the smaller gear times the angle in radians that the smaller gear displaces or moves. And that needs to be equal to the radius of the larger gear times the angle that the larger gear moves, which is actually what it is we are trying to find. Okay, but once again, these have to be in radians. We know that the smaller gear rotated an angle of 150 degrees. Okay, so we need to convert that to radians. We can do that by multiplying this by pi over 180. Now what you'll notice is that both 150 and 180 have common factors of 30, and we can write this as 5 over 6 times pi. Okay, and that is and that is the angle that the smaller gear moves in radians. Okay, we know the radius of the smaller gear, we know the radius of the larger gear. The only thing we don't know, and what we're trying to find, is the angle that the large gear moves. So we can solve for the angle of the larger gear, and that will give us that theta L is equal to RS theta S over theta R. I'm sorry, RL, sorry. And we can go ahead and substitute. We have 3.6 for the smaller radius. We have 5/6 pi. And then we have 5.4 for the radius of the larger circle. It turns out that this simplifies to 2/3. Well, these actually have common factors of 1.8 times 5 pi over 6. We can simplify that even more, and that will give us 5 pi over 9. And that is our answer in radians. Of course, we need to put this into degrees. And how can we do that? Well, we can actually take our value of 5 pi over 9 radians and multiply that by 180 over pi. And let me do this up here. So we have that theta L is equal to 5 pi over 9 radians. We need to convert that to degrees. We can do that by multiplying this by 180 over pi. Well, conveniently, the pi's cancel. Oh, the pi's cancel. It turns out that that 9 divides 180. So this becomes 1, and then this should become 20. And then our final answer will be that the angle traveled by the larger gear is going to be 100 degrees. 5 times 20 is 100. And there we go. That is our answer. Okay, the last thing that we want to talk about today, or at least that I want to talk about today, is the area of the sector of an angle. Okay, now we all know, or at least I hope you all know, that the area of a circle is pi r squared. And we can also tell that the sector of a circle is the portion of the interior of the circle intersected by a central angle. And also what I hope you can tell is that a sector is equal to theta over 2 pi of a circle. For example, if theta is right here, well then theta would be pi over 2. And pi over 2 pi, well, that's 1/4. This is a quarter of a circle. If theta was here, well then we would have that if the sector was this, well then the angle would be pi, and that would be 1/2 of a circle. And similarly, if we went all the way around, it would be a full circle. So it turns out that the sector is basically theta over 2 pi of a circle. The angular measurement of the sector is theta. If that's the case, well then the area of that sector is going to be the area of a circle times the fraction of the circle that the sector occupies, which would be theta over 2 pi. And if you simplify, of course, you will get 1/2 theta r squared. Okay, so we can go ahead and use that for an example. And this happens to be our last example here. We want to find the area of a sector having radius 15.20 feet and a central angle of 108 degrees. Okay, well, to do this, the first thing we need to do is convert to radians. And that will be 108 degrees times 180 over pi. No, I'm sorry, pi over 180. And we've actually done that before. That is 3/5 pi. They both have, remember, 108 and 180 both have common factors of 36. Once we've done that, so this is our theta, Once we've done that, we can go ahead and use our little formula there. That is that A is equal to 1/2 15.20 feet. We're going to square all that, and we are going to multiply that. No, we're going to multiply that by 3/5 pi. And that will give us 217.75 feet squared. If I wanted to round this to the nearest decimal, to the first decimal place, this would round to 217.8 square feet. And that is all I have for this particular section or this video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.